Okay, this is section 2, Vectors in Space from chapter 11. This section we are looking at vectors in 3 dimensions. So all of the formulas that we're going to be using are the same formulas we learned in chapter 6 when we talked about vectors originally. It's just now they're in 3 dimensions, so we're adding that third component having to do with the z-axis. So component form of a vector is written in brackets, v1, v2, v3, representing each component of the vector, kind of like an ordered triple. To get the component form of a vector, you do the terminal point minus the initial point. So if they give you 2 ordered triples, you do the terminal minus initial. The 0 vector is at 0, 0, 0. Unit vectors I, J, and K. I is 1, 0, 0, J, 0, 1, 0, and K, 0, 0, 1. A standard unit vector written in a linear combination would be V1I plus V2J plus V3K. The magnitude or length of a vector can be found by doing the square root of u1 squared plus u2 squared plus u3 squared. This is very similar to the distance formula. And then a unit vector can be found by taking the vector and dividing each component by its magnitude. Okay, the sum of 2 vectors is as simple as it looks. When you're adding 2 vectors, you're going to add the components of the vectors, and your result is also a vector. A scalar multiple, a scalar is just a number, c. When you multiply any number times a vector, it's like you're using the distributive property, so you just multiply that number times all of the components of the vector. The dot product of 2 vectors is kind of like multiplication, or it's a type of multiplication with vectors. You're going to multiply each component of the vectors and then add those together. The answer that you get when you do the dot product is not a vector, it's actually a number answer, so it would be a scalar. To find the angle between 2 vectors, you use the formula cosine theta equals u dotted with v over the magnitude of u times the magnitude of v. To get theta, we would take the inverse cosine of anything that we get on the right-hand side. So whatever the answer is on the right, take the inverse cosine. Make sure that you're in degree mode to get theta. Orthogonal vectors are vectors that are perpendicular. To determine if 2 vectors are perpendicular, you can do the dot product, and as long as the dot product equals 0, then they are orthogonal. Parallel vectors are multiples of each other, so if one vector is a number times all of the components of another vector, then that would be considered parallel. And then points are collinear if their vectors are parallel, and we're going to look at examples of all these here in just a second. So example 1 says to find the component form of the vector, find the magnitude and a unit vector in the same direction. So we're given 2 ordered triples, an initial point and a terminal point. So to find the component form, we're going to do the terminal minus initial. So that's going to be 1 minus a negative 6, comma, negative 1 minus 4, comma, 3 minus a negative 2. And I've written them in the angled brackets to indicate that this is a vector. So when I subtract these numbers, I get that the component form of this vector is 7, negative 5, 5. Now to find the magnitude of this vector, we're going to use the distance formula. We've already done the subtraction part, so all we need to do now is square each component, add them together, and then take the square root. So the magnitude of this vector v is going to equal the square root of 7 squared plus negative 5 squared plus positive 5 squared. So squaring each term, I'm going to get the square root of 49 plus 25 plus 25. When I add those numbers together, I get the square root of 99. And the square root of 99 simplifies to 3 square root 11. Now we need to find a unit vector in the same direction. So I'm going to take the vector that I've already found in component form and divide it by the magnitude of this vector. Now we could divide each of these components on the top by the magnitude, and that would give us the unit vector. Since I have a square root in the denominator, I actually need to rationalize the denominator. So remember, you would multiply times the square root of 11 on the top and bottom. So that would be square root of 11 over 3 times the square root of 11 times the square root of 11, which would simplify to 33 on the bottom. And instead of distributing this fraction with the square root throughout, I'm just going to leave it as the square root of 11 over 33 times the vector 7, negative 5, 5. If you want to distribute, you can, or you can leave it this way. Okay, number 2, we're going to find the vector z given the following. So we have vector u is at negative 1, 3, 2. Vector v is at 1, negative 2, negative 2. Vector w is at 5, 0, negative 5. To find vector z, it is equal to 2u plus 3v minus 1w. So first thing we're going to do is plug in our vectors where they belong. So 2 times vector u plus 3 times vector v minus 1 times vector w. So we're going to distribute the number in front, which is called a scalar, into the vector. So 2 times negative 1, 3, 2, and then 3 times 1, negative 2, negative 2, and negative 1 times 5, 0, negative 5. I get negative 2, 6, 4, plus 3, negative 6, negative 6, plus negative 5, 0, 5. Then when we have 3 vectors that are being added together, we're just going to add their components. So I'm going to add negative 2, 3, and negative 5. Then I'll add 6, negative 6, and 0, and 4, negative 6, and 5. The resulting vector z will be negative 4, 0, 3. Number 3, we're going to find the dot product of u and v. The dot product is a type of multiplication with vectors. So when we do the dot product, we multiply each component of these two vectors, and then we're going to add those together. The answer that we get will be a number answer, which is called a scalar instead of a vector. So we're going to do 4 times 2 plus 4 times negative 5 plus negative 1 times negative 8. So this will give us 8 minus 20 plus 8. So when I add those numbers together, I get that the dot product between u and v is negative 4. Number 4 says to find the angle between the vectors. So these vectors are written as a linear combination. I would write them in component form before I find the angle between the vectors. So vector u is the same as the vector 10, 40, 0, and vector v is the vector 0, negative 3, 8. The formula for the angle between two vectors is cosine theta equals u dotted with v over the magnitude of u times the magnitude of v. So we have 3 things that we need to find before we can plug into this formula. Let's start with the dot product. So u dotted with v is going to be 10 times 0 plus 40 times negative 3 plus 0 times 8. So the dot product will simplify to equal negative 120. Now we're going to find the magnitude of each vector. So the magnitude of vector u is going to be the square root of 10 squared plus 40 squared plus 0 squared. So when we simplify and add this together, this will be the square root of 1700. I'm going to leave this as the square root of 1700 and then simplify later when I'm finding the angle. For the magnitude of vector v, this is going to be the square root of 0 squared plus negative 3 squared plus 8 squared. So this simplifies to the square root of 73. So now I'm going to take my 3 pieces that I found and plug them into the formula. cosine theta equals negative 120 over the square root of 1700 times the square root of 73. Like I said earlier, to find theta, then we will take the inverse cosine of both sides and type this into our calculator. So inverse cosine of negative 120 over the square root of 1700 times the square root of 73. And make sure that you're in degree mode. You should get that the angle between these two vectors is 109.9 degrees. Number 5 says to determine whether u and v are orthogonal, parallel, or neither. So like I said earlier, orthogonal vectors mean that they are perpendicular and their dot product would equal 0. If I multiplied each component together and added them, they should equal 0. If the vectors are parallel, then they are multiples of each other. That means I can multiply some number times one of the vectors and it will equal the other vector. And then if it doesn't fit either of those rules, then they are neither. So what I'm going to test first is to see if they are parallel. So I'm going to take each component and I want to divide these out to see if they equal the same number. So if I do negative 12 divided by 8, 6 divided by negative 4, and 15 divided by negative 10, all of these equal negative 3 over 2. So since they all divide to equal the same number, that means they are scalar multiples of each other and they are parallel vectors. Number 6, we're going to determine whether the points are collinear. So in order for these three ordered triples to be collinear, their vectors would have to be parallel to each other. So I'm going to find two vectors. I'm going to find vector AB and vector BC. So vector AB, you take the B vector or the B point and subtract the A point. So if I do 7 minus 5, that's 2. 3 minus 4 is negative 1. And negative 1 minus 1 is negative 2. Then for vector BC, I take the C components and subtract the B. So 4 minus 7 is negative 3, 5 minus 3 is 2, and 3 minus a negative 1 is 4. Once I have two vectors, then I can do the same thing that I did on the last problem to see if they are parallel. I need to see that if I can divide the numbers out, that they will equal the same number. So if I do 2 divided by negative 3, I want to see, does that equal negative 1 divided by 2, and does that equal negative 2 divided by 4? Well, 2 of those will divide out and equal 1/2 or 0.5, but 1 does not. In order for these to be parallel, they would all have to divide and equal the same number. So since they do not, they are not parallel and not collinear.